See, next is the analysis of the truss. So in the analysis of the truss, there is a method of joints and method of sections. So in these two methods, so we are analyzing the truss. So truss, we know that whatever the structure below the sheets, or whatever the gallon sheets or the any concrete sheets are there below that, whatever the truss, the steel frame structure will be, so that will be the truss. So in this method of the truss, so consider this is a simple truss. Okay. So how to analyze the truss, how to work the problems on the truss problem. Let's go one by one. See here, here the problem is find the forces in the all the members of the in the given truss shown in the figure by using the method of joints. Okay, so first I will tell you how to do the problems on method of joints. See, this is the given section, this is the given truss problem. Okay, so you know what is this and what is this. So this is an hinge and this is a roller. There will be two reactions in the hinge and there will be one reaction in the roller. Okay, so this is all the 20, 30, 10 kilonewton is the forces. So respective, these are the frames. So whatever the truss will be there, that will be the frames. So here on top of it, the sheets will be laid. Okay, sheets will be laid at this end. Okay, so this will be the whatever the this truss will be there, it will be standing like this. So one after the other on the walls it will be placed. So on top of it, the roof, the sheets will be like this, like a slant, it will be placed. Okay, so this is what the truss you have to be analyzed. So don't worry about all those things. So given truss will be like this. So what you have to do is you have to select a point. Okay, so there will be a force reaction will be there. For the force reaction, for each point, each you have to take a nodal point. Okay, so how you are resolving the point, all the forces which is acting at a singular point, you have done the problem now. Like that, each point you have to take it and you have to solve it. Okay, see here you have to find out this is the AC member, this is the AC member, this is the CD member, and this is the CF, and this is AF. Okay, this is FG and DG and GE, and this is the DE member. So this is the EB and this is the GB. So these are the members. Okay, so these are the members. So what you have to do is, so you have to find out the forces in this member. So you have to find by using the method of the joints. So first you have to select a point where is a three forces where where is a two unknown and a one known forces. Okay, so like that you have to choose, and by that you have to go further further finding the forces of the rest of the members. So this is how the process of moving forward. Okay, so first what you have to do is you have to find out the distance. See here, when you see the member, see first what you have to do is this is the size, from here to here 3 meter they have given, here to here 3 meter they have given, here to here 3 meter they have given. So here if you cut exactly, so the angle here to here they have given the 60 degree. Okay, so as soon if you see the member, see exactly if I cut here and if you fold it, it will exactly prismatic. This half of the section is similar to that of this half of the section. So as soon you see the similar section, so you have to remember that you need to determine only half of the section. This section, this one, this member, this member, this member, this one, and this one, and this one. So this member will be equivalent to this member. This member will be equivalent to this member. So this will be equivalent to this member. Okay, FG is the common. Okay, so this is the prismatic, and so this is the prismatic. So what you have to do is first initially you try to know the distance. Okay, so what is the distance you need to determine? Okay, see here you know the base distance, but this the whichever which is the inclined in the position where that is AD and BD, it is remain unknown, so you have to determine. So how to determine that? What you do is you just cut the section like this. Okay, you cut the section like this. See here, this is the triangle. You have to find out the this distance and this distance. So what you do is, this is the 60 degree. Okay, so this is 60, this is 60, this is equilateral triangle. Okay, this is 60, this is 60. Obviously this will be the 60 degree. Okay, so that's what I'm shown here. This will be 60, this will be 60, 60 and 60. Okay, see here, this is the line where this is the perpendicular line to this baseline. Okay, so obviously this will be 90, this will be the 90. Okay, so this will be the 90, this will be the 90. In the question only they have given one side, it is 30 degree. Okay, so obviously this will be 30 degree means, okay, so this will obviously this will be 30 degree, this will be 90 degree means 30 plus 90, it is 120. Obviously this will be the 60. So this is 60, this is 60. Obviously it will be 60 degree, because here it is the total angle is 180. Here 60, here 60. So 180 minus 120 is 60. This will be the 60. Okay, so I will write it. This is 90, 90, and this will be 60, and this will be the 60. Okay, so now I want to determine this. Okay, you take a, this is the H. Okay, see here, triangle AHD as a triangle. Okay, so take tan theta. Tan theta is equal to opposite by adjacent. So here it is 30. From a mid, from here to here distance is 3 meter. So mid will be half of it. Okay, so it will be 1.5 meter. 3 plus 1.5, it is from here to here. A to H will be 4.5 meter. Okay, so this is 4.5 meter. This is an unknown distance. This angle is 30 meter. So this distance will be found out by, here I am written, see here, tan theta is equal to tan theta is equal to opposite by adjacent. So opposite is DH is the opposite, is equal to tan theta into adjacent. Tan theta is, here it is 30 degree. Okay, because I am taking this complete triangle. Okay, so this is 30 degree. So this is tan 30. Okay, so this adjacent distance is from here to here, A to H is 4.5 meter. So that is I have written. Okay, so opposite distance, that is DH is equal to, so if you calculate this, you will get 2.59 meter. Okay, from here to here it is 2.59 meter. Okay, so take this one as a triangle. Okay, this one as a right angle triangle. So this length, this one length, this length, and this length, you know, you should know this length. This is hypotenuse. So hypotenuse is AC. Okay, you take one. Next is the, if I want to find, you want to find out the distance AD. So what you take? You take this one as an hypotenuse, DH and AH as the other side. So take a hypotenuse. So it will be AD square is equal to AH square plus DH square. Okay, so that's what for here, 4.5 square plus 2.59. Okay, this is 2.59, this is 4.5. Okay, so the both of the square and the square root AD square is there, you send the square root to this side, so it will be square root of 4.5 square and 2.9 square. Okay, finally the AD, whatever the AD distance, you will get it around, that is 5.19 meter, you will get it. Okay, so 5.19 meter, you will get it. So there is a one thing, so this whatever the perpendicular will be there, that will be placed exactly. The figure is not exactly same, but 2 times of AC, the length AC is equal to CD. Okay, so whatever the distance will be there, so AD distance is 5.19, half of it will be the AC distance. Half of it of AD, that is 5.19 divided by 2, that is 2.59, will be the 2.59 distance is the AC distance and as well as the CD distance. Okay, so that's what the length measurement of this one. Okay, so this is what the first part. Next part is, after finding this distance, next you have to find out the equilibrium equations. So you have to find out the reaction at A, VA and horizontal A, because here hinge will be there, one vertical force and horizontal force will be there, and here there is a one vertical force will be there. Okay, so that's what I'm shown here, one horizontal force and one vertical force. Here there is only one vertical force, because here there will be only roller. Okay, so how to solve that? Okay, I will show you. I'll show you. See here, I'm taking the moment at a moment at a I'm taking. Okay, so this will be the one, there will be one, this is VA. Okay, so there will be here another one VB. Okay, another will be horizontal force. Okay, so that is HA. So due to hinge is there, so that's why two force. Okay, hinge is there, that's why HA and VA, two forces are there. So I'm taking moment at A to remove the two unknown forces. Okay, there is only now one unknown force. Okay, so VB is there, VB into this distance, VB into 9. Okay, next force is this one, 20 into this distance. This distance is 2.24, you will get it. So how you will get 2.24, I will tell you later. Okay, so from this force to this A, the distance is 2.24. okay, it exactly, it will proceed like this. So this force into this distance 2.24. okay, next is the 30. okay, this force I have taken, this force, so 30 into this distance, that is from here to here distance is 4.5 meter. okay, so that's why here it is written as 4.5. okay, 30 into 4.5. next is this force, so this force will be acting here. okay, so this force into this distance, 10 into this is the total distance is 9 meter, so 9 minus this distance is 2.24. okay, this distance is 2.24 from exactly the line of action from this force to from here to here, it is 2.24. So this force into from here to here distance is force into distance, no, 10 meter into this distance, 9 minus 2.24 meter, from here to here it is 2.24, so that's why you have to minus, so that's why 10 into 9.24 meter. okay, so then you calculate, you do the calculation of this, so finally the VB reaction will be 27.48 kilonewton. Next is the, see here, before that, this how the 2.24 distance will comes, I will explain, I forgot to tell you. See here, this is the truss problem. See here, now consider this force which acting, line of action will be, because this is the slant, it is by acting like the slant, but the force will be acting exactly vertical to ground 90 degree. okay, so line of action will be attains here. So x, consider this point is an x. okay, so from here to x distance you have to determine this angle is 30 degree, this distance is 2.59. so what is this side is, this is the angle, so it will be seeing here, so this will be the opposite and this will be the adjacent. okay, so you need to determine ax distance. so ax is nothing but adjacent, so you will get adjacent in cos theta. okay, so that's why you take cos angle. So you take a triangle AXC, that is AXC. okay, in this cos theta is equal to AX divided by AX cos theta. Cos theta is equal to adjacent by hypotenuse. Adjacent is AX, hypotenuse is 2.59. so AX divided by 2.59. so theta angle, you know, cos theta, AX is equal to, finally AX you will get it as 2.24 meter. okay, got it, 2.24 meter you will get it. So that's what the answer. okay, so this is how you will get the distance EX. okay, I forgot to explain. Now you got, no, how you got the distance of EX. Okay, now we will find out the vertical forces. Okay, see here, next vertical force you have to determine. Now I have determined the VB, the vertical force VB I have determined. Now I want to determine the VA. So there is only two forces now. There is only two forces, one vertical force and two vertical force and one horizontal force. I know this one, I can find out this one easily. Take summation of vertical forces. Okay, so upward, you take upward as positive forces. Okay, VA and VB both are positive, so that's why VA VB are positive. So this is acting, these the 20 30 and 10, these three forces acting negatively, so minus, so minus 20 minus 30 minus 10, so is equal to 0. So summation of the forces, you add it all together, that is equal to 0. So if you calculate this, the finally VA will be, you will get it around 32.52. Now you have determined VA, you have determined the VA force and VB force. Now you have to determine the horizontal force HA. Okay, so due to there is only one force, there is no other force, so that's why obviously HA will become 0. Okay, so if there is any forces, HA will be, so you can take it, force which is acting in the right hand side is equal to 0, and you can take the whichever force which is acting in which direction, either left side it is moving or right side which is moving, you can take it and you can solve it. But there is only one force, so that's why this force will become 0. Okay, so this is the first part. Okay, next what I will do is, I will take, see here, VB I know now, because VB I determined just now. Okay, this one VB I have determined. This if I take means, see, this is the one force, this is the VB force. Okay, if I take the free body diagram of this one, this is the VB. Okay, so there is a one horizontal force, so you have to consider this one, it is moving from away from this point. Okay, GB, so this is the GB force. Okay, force GB, and this force, another force BE. Okay, force BE. So now I have drawn the free body diagram of point B. Okay, so this angle which is acting at an angle of 30 degree. Okay, now I want to find out this force and this force. So every point I should go this point, this point, and this point, and this point, and I have to find out the respective forces. If I found this one, this force, this force, this force, this one, and this one, and this one, so that will be respective of the rest of the forces. Okay, so that one, how to solve that, I will tell you in the next video.